Good afternoon, everyone. Welcome back, and thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yeah, and we were talking about this is kind of a topic of space and technology. Has to do with um, spacecraft and how they're going to get around, or hopefully get around differently. I
Yeah,
guess if I'm understanding this correctly. So
yeah.
kind of cool.
All right, here we go. Future spacecraft may travel farther by drawing momentum from planets, sunlight, and the solar wind instead of onboard fuel. Every conventional rocket faces the same problem. It must carry the material that propels it. Since Konstantin Tsiolkovsky discovered the rocket equation in 1903, probably the thrust equation, spacecraft have burned fuel and expelled it backward to move forward under Newton's third law. But adding propellant also adds weight, which demands still more fuel to accelerate the heavier vehicle. This compounding burden places severe limits on missions and makes travel between stars appear extraordinarily difficult. What if the spacecraft could move without carrying propellant? Would you like to know more?
That would be cool because I mean, think about all the fuel that they expel from takeoff till they
Yeah,
get out of the atmosphere.
out of the atmosphere. Yeah.
Yeah, that's an extraordinary amount of fuel. So, a comprehensive review explores that possibility by examining propellantless propulsion technologies for spaceflight. Instead of relying on chemical combustion, these approaches draw energy or momentum from forces already present in space, potentially supporting missions that conventional rockets could not accomplish.
So this is all and good if you're in orbit, but to get off the Earth, get out of the gravity, you still need that propellant. And then let's say you land somewhere, you're going to need propellant to get off wherever you land.
Get out of that gravity, right?
Yeah.
Yeah, or
Okay.
that.
The gravity assist is the most established propellantless method and has guided spacecraft for decades. Engineers send a spacecraft past a planet at a carefully chosen time and angle, allowing it to take a minute share of the planet's orbital momentum and gain speed without burning fuel. Voyager used this strategy to reach all four outer planets. Its major limitation is timing. The required planets must be properly aligned so that launch opportunities are uncommon and possible routes are restricted.
So I wonder if this is kind of like a hybrid car. So a hybrid car, you get going, right, and you're using fuel, and then once you get going, and maybe some you can use the battery if you're just tooling around town, but
Or going downhill.
going downhill, you can switch to the battery. But yeah, I don't know, maybe so. Solar sails offer more continuous and convenient propulsion by harnessing radiation pressure from sunlight. These enormous membranes reflect photons to generate thrust, accelerating slowly but persistently without fuel. Japan's IKAROS probe demonstrated the technology in 2010, successfully traveling to Venus on sunlight alone. Wow. Okay.
I haven't heard of that. That'd be a nice story.
Yeah. However, solar sails require vast
Gossamer.
gossamer thin materials that must survive harsh space conditions for years, and their performance drops dramatically with distance from the sun. So that could be a problem.
Yeah. I mean, trying to get from one sun to another, that could be a problem.
Yeah.
So, magnetic sails take a different approach, using superconducting loops to generate powerful magnetic fields that deflect the solar wind, the stream of charged particles constantly flowing from the sun. By pushing against this plasma, magnetic sails create thrust without consuming propellant. They potentially offer better acceleration than solar sails and wouldn't degrade over time like reflective membranes.
The catch, creating the necessary magnetic field requires enormous superconducting coils, potentially 50 kilometers in radius.
That's a lot. That's big.
Pretty big, yeah. That's pretty big. maintained at a cryogenic temperatures. The technology to build and deploy such structures simply does not exist yet.
Yeah, cryogenic. That's deeper than space. I mean, space temperature. Space temperature is cold, but cryogenic is even colder. Electric sails represent a newer variant, using charged tethers rather than magnetic fields to propel solar wind protons. You could do this with a nuclear plant on the spacecraft. These systems promise lighter spacecraft than magnetic sails, though they too depend on deploying extremely long, lightweight wires and require significant electrical power to maintain the necessary charge.
Each propellantless method offers unique advantages while facing distinct engineering hurdles. Gravity assists work now, but demand precise planetary alignments, which, again, what we were just talking about, right? Going from sun to sun.
Yeah.
Solar sails provide steady thrust but need massive, delicate structures. Magnetic and electric sails avoid material degradation, but require technologies still in development. Maybe Elon's working on that.
Yeah, maybe. The review makes clear that no single approach solves every challenge, but together these methods could fundamentally transform how we explore the solar system and beyond, to infinity and beyond. For truly ambitious missions to interstellar space, leaving the propellant behind may not just be advantageous, it may be absolutely essential. But that's scary. That's like, how are you going to find more propellant where you're going? What if there's no propellant?
Yeah, exactly.
No water to split from hydrogen and oxygen.
Yeah, it's like stranded on the 15 freeway between Barstow and Baker and State Line.
Yeah,
not much out there.
No,
much out there. So,
no.
Whether you need fuel or you need charging, there's not much out there. So,
not much out there. Yeah.
Anyway, interesting story.
Yeah.
Maybe it'll happen though. We'll see.
All right, folks. Thanks for joining us. We'll catch you in the morning.
Take care, everyone. We'll see you tomorrow.